This is 5-6, solving systems of linear inequalities. So just like we did with systems of equations, it says to tell whether the ordered pair is a solution of the given system. So we're going to plug in the 2 and the 1 into the x and the y. And we're going to solve both of these and see. Is 1 less than negative 2 plus 4, which is 2? Is 1 less than 2? Yes, it is. Is 1 less than 2 plus 1, which is 3? 1 is less than 3. Less than or equal to, 3. So this is a yes. For example B, plug in the 2 and the 0. So 2 goes into the x position, and 0 goes into the y. Same for the bottom one. And then calculate. Is 0 greater than or equal to 4? No, it's not. And is 0 less than 3? For this one, it's a yes, but for the first one, it was a no, and so therefore it's a no. It has to be both, has to work for both of them to be a solution for the whole system. When you graph a system of linear inequalities, you're going to be shading both inequalities like we did in 5-5, and you're looking for the overlapping shaded region. So where they're both shading, like a double shading, which I'm highlighting right here, I'll do it in red and blue. This double shading is the solution to the system. So we'll take a look at these. Remember that in order to graph, we always have to have isolated equations. We need them to be in y equals mx plus b. So for my first equation, my second equation is already isolated. I'm going to take a look at my first equation. 8x plus 4y is less than or equal to 12. So if I'm isolating y, I need to get rid of this 8x. So I subtract 8x from both sides. 4y is less than or equal to, I always write the x first, so negative 8x, and that's a positive 12. So 12. Divide by 4 to everything. When we multiply or divide, we do it to all terms. So y is less than or equal to negative 2x plus 3. Okay, let me graph my first one in red. Let me mark it like this. So y equals 1/2 x minus 2. We begin at the y-intercept, negative 2. And then we rise 1 and run to the right 2. There's my first line. Sorry, since this is a greater than sign and not equal to, this is a dotted line. And then we need to test a point to see which side we're shading. So if I test the point 0, 0, I put in 0 into that equation, and this is the inequality. 0 is less than 1/2 times 0 is 0 minus 2. So greater than, I said less than, I think. 0 is greater than negative 2. Is that true? Yes, it is. So I'm actually going to shade the side that includes 0, 0, since it was true. Then we look at the second inequality that we have to graph. We're going to begin at positive 3. Oops. On the y-axis. And now I need negative 2 over 1 for my slope. So that's down 2 to the right 1. Down 2 to the right 1. You can actually see where they're meeting. And this is a closed line, a solid line, since it was equal to. And again, I have to test a point. I can test 0, 0. So 0 is less than or equal to negative 2 times 0 plus 3. Well, that's just 0. So 0 is less than or equal to 3. 0 is less than 3, so that's true. So I'm going to shade the side that 0, 0 is on compared to this blue line. So I would be shading this side of the blue line. Blue and red make purple. Can you see the purple area? That is the solution. These inequalities are already isolated, so I'm going to go right to negative 3. Oops. On the y-axis, and I'm going to rise 2 and run 1 from my slope, 2 over 1, and that's a dotted line because of the less than, so they're both going to be dotted lines in this case because these are not equal to, they're just less than or greater than symbols. And I'm going to test my point, so I can pick 0, 0 since it's not hitting 0, 0. 0 is less than 2 times 0 minus 3, so 0 is less than, I could just cross that out, negative 3. Is 0 less than negative 3? No, 0 is greater than negative 3. So I cannot shade where the side that 0, 0 is on. So if this is my boundary, then I'm going to shade the right-hand side, or the bottom, however you want to think about that. Okay, in my next inequality, I'm going to begin at positive 2, and the slope is 2 over 1 again, same slope, 1, 2 over 1, 1, 2 over 1, dotted line. And let's check our point 0, 0. So 0 is greater than 2 times 0, which we don't need, plus 2. Is 0 greater than 2? No, it's not. So we can't shade the side that 0 is on. I cannot shade that side that I just made a dot at, so I'm going to shade the other side. So here's my solutions. I'm sorry, so they don't cross anywhere, so this is no solution. There's no purple where the blue and the red mix. And okay, here we have two inequalities that are already isolated. I see that the first one is going to be dotted and the next one's going to be solid. So let me graph my dotted line, begin at -3, rise 1 and run 1. Okay, and then let's graph the y is less than or equal to x plus 1. So I'm going to begin at +1, rise 1, run 1. And that's a solid line. Oops, I forgot to shade. I like to shade one at a time, so let's do that. So for the first one, if I pick 0, 0, then 0 is greater than 0 minus 3. I'm going to just ignore the 0. 0 is greater than -3. That's true. So I'm going to shade. Oops. I'm going to shade where 0, 0 fell compared to the red boundary line. See, it gets confusing when that blue line's in there too, so that's why I like to do one line at a time. So for the other inequality, I begin at +1, I graph my line, and I'm going to test a point. So I can test 0, 0, so 0 is less than or equal to 0 plus 1, which really just means that 0 is less than or equal to 1. And is that true or false? Is 0 less than or equal to 1? It's true. So I'm going to shade the side that 0, 0 falls in. That's true. And so the part where there was red and blue, this time it didn't blend for me, but I'll make it purple for you guys so you can see it. These are where the solutions were. Okay, these are also isolated, so I have two solid lines this time based on these symbols having the equal to. So the first one I'm going to begin at -2, and I'm going to go down 3 into the right 1. 1, 2, 3, always to the right, remember. And if you notice that my line is negative, which is what I wanted. So get my solid line in here. Let's test our 0, 0. 0 is less than or equal to -3 times 0 minus 2. So 0 is less than or equal to -2. That's not true. So that's false. So I cannot shade the side that has 0, 0, which would be the right side in this case. So I'm shading this side. Okay, and then let's get in our other point. So I'm going to begin at 4, our other line, I mean. Down 3 to the right 1, down 3 to the right 1. These were actually parallel. I just drew that kind of poorly. 1, 2, 3, 1, 1, 2. Okay, and test our point. 0 is less than or equal to, I don't even need that because we know it's going to be 0. So 0 is less than or equal to 4. Well, that's true. Since that's true, I have to shade the side that has 0, 0. And so you can see where my solution is going to be. That one blended better. This is where my solution falls.